Hi everyone. In this video I'm going to be going over this Grasshopper script that allows you to create a parametric egg-shaped form that is able to be closed and 3D printed. Now I've already baked this one, and so let me ungroup it and show you, what it allows you to do. It'll create kind of that lip in an enclosure, and it'll create that egg form also with a base. So let me delete this and show you, some other parameters. You can increase, the size of the egg or decrease it. The other thing you could do is kind of adjust the scale. So if you want it just a perfectly round circle, you just go to 1, so it scales it to 1, and that could, that could be what, if that's what you want, that's what you could use. Let me show. This is the opening location, so if you can vary that also. You can put it in the middle, you can put it a little bit higher, you can put it a little bit lower. So these are the things that you're able to kind of adjust with that with this script. Now let me show you what else it can do. This bottom part here, it could clip less or more, it depends. If we go to 20, it creates a smaller like a bigger base, but we could go to 5, it makes that we can increase also the thickness of the whole egg. So if we go to 6, you can see that it'll increase that also. There are many things you can adjust here. So there's a lip here that allows you to close it down. Obviously there's certain parameters that if you go too far you have to adjust. So I'll be going over all of the steps for how to create this, and I'll also be going over the final product, which is going to be a 3D printed egg, and that's because that's something that my daughter really likes. She likes the surprise eggs, and so this is that inspired me to create this tutorial, so I can make a bunch of different ones and give them to her and she could play with them. So okay, so let's start with the basic form that we're going to use, which is going to be a sphere. And this sphere is going to be in the 0, 0, 0, and we're going to give it a radius of 50. So the diameter is going to be 100, and this the units I'm using are millimeters. So we're going to start with that sphere. In this sphere, what we're going to do is deform it by scaling it. And so the component I'm going to use is scale, but not this scale. It's going to be scale the object in non-uniform. So we're going to plug in that geometry, and then we're going to go from 1.0 ... to 2. And what that does is gives us a range from 1 to 2 with with 1 unit over here, so we can get a little bit closer to what we want. So at 1 it's the same, and if we go here we can start increasing it to kind of get that egg shape that we want. So let's leave that at 1.6, and let's unpreview this. The next step we're going to take is to create the base. So right now, if you had this form 3D printed, you couldn't really sit it on anything because there wouldn't be like a flat bottom. So what we're going to do is create a box. And so one of the ways that I create a kind of bounding box around it is creating you bring in this box container or component, and you put it here, and it just creates a box around it. But there's also a bounding box command that does the same thing. I just like a smaller component, and that's kind of all we're gonna need. So that's why I use this one instead of the other one. And now that we have this box, what we're gonna want to do is take this geometry, the bottom part of this, and extrude it up. And so to do that, we're gonna have to deconstruct the B-rep. What that does is it basically explodes it into all these various faces, edges, and vertices. But for now, we're just going to use the faces. And I'm going to go ahead and actually select both of these, do a spacebar, and unpreview it so I can go to a list item. So a way to just get one of the components or one of the faces that we exploded is to go to a list item. And this is a component I use a lot because a lot of geometries have more than one thing that you want to use. And so by taking, let's say, all these faces, which is 6 obviously because we're using a box, we put that in there and we see that we have the left one that is the default of 0. But if sometimes we reverse it, now we see that it selects something else. So depending on how the list is created, we can reverse it or keep it as a default to get the different faces or whatever we're looking for. So now that we see that the default of 0 is the top one, usually when it's when it starts with the top, usually the next one, which is the number 1, is the bottom, and that's what we want. So you can create a slider and leave it here, or you can right click here, you can delete this and right click, go to set integer, and just put 1 here. And since we're always going to want that to be the bottom, we don't need a slider because someone might come in and try to move that slider and it'll just kind of mess up the whole script. So let's keep that there. And now we have that surface. We can take this surface and we can extrude it. So we can take that, extrude it, and usually when you want to go up, you go in the Z direction. So we want to extrude it up, and it defaults to 1 here. So let's do a 1 ... to maybe 50. So it'll give us, we can extrude it up to 50 if that's what we want, or we could do it less. And then, as you can see, we have that box, but we also have this plane. So we can go ahead, right click there and unpreview that. And now we have a egg shape, but we also have this bottom part, which we can adjust up and down. And with this geometry, what we're going to try to do is basically subtract. So we do a solid subtraction or solid difference, and we take the egg shape and we put in the extrusion that we took, and then we see the result is here, but we have overlapping geometry, so we can go ahead, go to these, spacebar, and unpreview those, and now we can easily adjust where we subtract the base of the egg shape. You could also go ahead, come here and say, I do like that sphere, or we can go a little bit bigger. It all depends on whatever you're looking to do. So now that we have this, we can move on to the next step. So now that we have that form, we want to cut it in half and have the top and bottom half. So to do that, we do a box again. So we're going to create a box around this, and this box we're going to move in the vertical direction, and it's going to default to going up to 1. But what we're going to want is do a division. We want to move this up half the height. So we can go ahead and just put the so now that we have this geometry, we're going to want to cut it in half. And to do that, we're going to want to create a box around it basically we're going to create the geometry that's going to subtract and create that middle cut. So we have the box, and this box we're going to want to move. So we put the geometry here, and we want to go in the Z direction. We want to go up, and what distance? Half of it, which is going to be basically the radius. And we could always adjust that later, but for now let's keep it at that radius, and let's see what it does. So we do have that box almost at the center there. So that's kind of what we want to create that cut. And so we can take this and we can hide it. We can see we have the shape intersected by the box. Now we're going to do intersection. So you could do intersection or you could do a difference. It doesn't really matter at this point. So let's do a solid difference. Solid difference. So let's go here. So we're going to subtract the box. So that goes to B, and we want to keep the egg shape. And so there we have the bottom part. We could also hide this geometry. So now we have, now we have the whole shape here. We have the bottom part, and to get the top part, we're going to subtract this bottom part from the whole shape. So let's subtract solid difference again. But what we want is to put this at the bottom, and then put this one at the top. And so there we have those two shapes. Now I'm going to hide this complete shape, and there we have the top and the bottom. Okay, so now that we have these two, top and bottom, we're going to want to give it a thickness, and the way to do that would be to take this geometry, which is the scaled shape, and we want to offset it. So we go here, and we'll give it a distance of 5, and let's see, it offsets to the outside. So to make this offset the other way, we're going to go ahead and create a negative, and so we can plug that in there, and now we can see that instead of offsetting out, we're offsetting in, and it's kind of hard to tell here, but you'll be able to see that on the inside. So let's see that. So yes, we have something in there. I think I'm picking up this other stuff, so let me hide it. And so, okay, so we have that thickness that we can adjust the perspective. So yes, we have that. We can change that depending on what we want. So we want it to start maybe at like 1. That way it doesn't, it has a thickness from the beginning to the end. So we have that. And so now that we have that offset, we can go ahead and just subtract that from these. So let's do a difference once again. We have the top and the bottom, and so I'm going to go ahead and hide them. And I'm also going to hide this, and I'll tell you why. It's because when we do a solid subtraction, I want to be able to see what pops up right away. So we have the top, which is this one, we have the bottom, which is this one, and now it's a matter of putting in that geometry that we just offset as the B. And so there we have the top, and let's plug that in once again down here, and now we have the bottom. But as you can see, we do have a hole here, so we'll have to adjust that, which is a fairly simple command. And let me give you an idea of what we have to do. So Remember back here at this step we do have the bottom part, but we also have this extrusion. Now we're going to use the top of that extrusion to extrude up and create that bottom part. So let me show you. Let's do a list item, or let's deconstruct the burette first. That way we have all the faces that we're trying to look for, and let's do a list item and plug that in, and once again it starts at the bottom. So let's see if we do an index. Let's do a see if 1 works. Nope. But let's try once again. Let's go here and let's do a reverse, and once we reverse it, the default of 0 gives us the top part. So that's what we want, and we go ahead and unpreview that and extrude this surface. We're going to extrude it how much, or in the Z direction, and how much? The same thickness as the outside. So what we used for the thickness was this one, so we'll plug in this, the thickness to the Z, and we'll take this plane and we'll extrude it up, and we can go ahead and unpreview this one to show you that we have created the base. And now for us to make it into a solid, we'll do an intersection. So solid intersection, we're going to intersect this bottom part with the original outside of the egg, or we could also do the inside of the egg, but I want to keep it on the outside one. So we'll do this geometry, we'll plug it into here, and if we hide this, we see that we have the base part of it. And it's just a matter of taking this one and doing a union. So solid union. So when we union it, we can go, like I said, I like to unpreview it, plug it in here, and plug it in here, and now we have, it'll give us a result of 2. So then let's flatten it, and that gives us one closed burette. Later on down the road, if you wanted to give it like a bigger base, you could go 10, and so you could increase the bottom part if you wanted to. But for now, we'll keep it with the default there. And so we have bottom, we have the top, and now we want to be able to, pull the top part off from the bottom, and that's going to require us to kind of create a lip right around here that allows us to close it down in the same way that you would do like an Easter egg. So that's kind of what I'm going to do on the next steps. Okay, so to create that lip, we're going to unpreview the top and just stick to this bottom part here, which we're going to once again create a box around it. And what we're going to do is select this top surface to see what the top surface intersects with, and then use that curve. Let me show you what I mean. Let's deconstruct this box. Let's go ahead and hide that box, and let's pick an item. So once again, list item, plug that in, and we see that we get the left one. Let's go ahead and reverse it, try it again, and it gives us the top. So now we can unpreview that, and we have this shape and the top surface, which we can go here to intersect, physical, and then we'll do 2 B-reps. So we'll take this B-rep, intersects with this B-rep, and it gives us a curve on the outside and a curve on the inside. Now we can, let's see how many items we have here. Let's do a panel just to see what we got. And we have two curves, one planar closed curve and one planar. So we have two curves basically. So let's go to a list item again, because we want to pick one of those two, and the default of 0 gives us the inside curve. So now we can go ahead and hide these, and we have created that curve that always intersects there. And how do I know that? Because when I move this up or down, it sticks to this curve. And so to give it some thickness, we want to offset it. So we offset it out, and we're going to offset it in. Since we're going to offset one out and one in, we know that one's going to go negative and one's going to go positive. So let's do a 3mm offset, and we'll do one there, and we'll plug this one here. And since we have that item, we can unpreview it and then plug it in here, and then plug this in here, and we have these two curves, which we can go here, and then what we're gonna do is extrude them, and that's what's gonna give us the lip for the top. So let's extrude it in the Z direction, and we're going to create a slider of 10. So there we have one. That's the outside one, and we'll cap it to make it into a solid, and we'll also do the same thing for this curve. So now we have the inside and we have the outside, and we could do a difference. Just subtract the inside one from the outside one, and we can unpreview those and clean this up a bit to show you how we have now that lip that's going to allow us to close that geometry, those two shapes. So this lip is, if we see here, we're gonna want to basically subtract this from that outside geometry. So let me show you what I mean. Let's do a subtract, a solid difference. We have this one, which we want to subtract, and we want to keep this geometry. So we've successfully kind of brought it over here to the end, and we'll unpreview that, and we can see now that we have something closer to what we were looking for. We can make the lip a little bit smaller. Let's make that a range. Make it a little bit bigger, a little bit smaller. Let's say 1.5. And so if we go ahead and bake this, let's do both of those. We have this one, so let's union. So we have this bottom part, we have the lip, and we have the top part. What we need is to solid union both of these. So I'll unpreview that one, and we'll bring this one over. And it gives us two objects which we're going to want to flatten, and that'll give us one closed B-rep. So we can go ahead and hide this one and do a bake. Okay, let me show you the results we get here. And what I'm going to do is show you a section of what we created. To do that, I create a line. I go here, bring it down, and I project it to here. And so we've created this little lip that's going to allow us to close it down. But as you can see, it's kind of a thin lip, so we're going to want to increase it and create a little slope here. That way we can print it correctly. Okay, so to be able to finish kind of creating this lip, which we want to basically create a little slope so it prints and so it's not so flimsy, what we're going to want to do is go to this view and hide the top part. As you can see, there's this lip here that it's going to make it tricky to 3D print, but it's a fairly easy thing to be able to adjust. So the way to do that is we'll have to preview these again, and we have the outside one and the inside one. We're going to take this outside one and we're going to move it vertically. We'll do it a default of 10 here. Take this one and move it basically down. So instead of moving it up, we're going to want to go negative. Put that in here, plug that in there, and plug in our geometry. So we have the bottom part, the top part, and this part. We're just going to want to loft together the outside and the bottom one, and we're also going to want to loft this inside one with the outside one. So now that we've created that, we can join them together. So that's called a B-rep join, and plug that in, plug this in. It's going to be this geometry and this inside one. And so if I unpreview that and plug this in here, we'll see that we have basically a solid B-rep, one close B-rep, and that will be what we want to union also with this, and that way we have created that slope that we were looking for, so we can 3D print and also make it more sturdy. So you'll see here we can decrease it or we could increase it. We'll keep it at 5. Okay, so now that we have the top shape and we want to create that slope, what I did was I took these two curves which were down here and I moved them up the same amount that the lip was extruded. So the lip was extruded 10 and I moved it up. Now what we want to do is do the opposite of what we did at the bottom. Instead of adding, we want to subtract that triangle so we can create that slope. So we're going to take this curve and we're going to move it up. And for now, let's do it up the same amount that we brought down that slope at the bottom. So we're going to move that up. We have that, and that upper lip part, we have the outside offset and we have the inside offset. So I'm going to unpreview these and I'm going to loft together these curves to create a solid. So we'll have this one and this bottom one create a lip. We'll have this outside one and the inside one that creates that lip, and we have this top one and the outside one. So we create that triangle, which we can now join together into a closed B-rep. So those are 3 surfaces into one closed B-rep. And now that we have that triangle, we can go ahead and subtract it. So we want to keep the top shell, and we want to subtract it from the bottom shell. So there is that little slope that we want. But as you can see, we're getting a bit of a weird overhang on this side. We have this like up, down, and then up. So to be able to adjust that, we want to offset this in an amount. So which one is that? Which curve is that? It's going to be this top one. We're going to offset it. I'm going to say 2, just to be safe. And so when we offset 2, we see that it offsets out. We want to go negative. We want to offset the other way. Now we can see that we have offsetted in. So wherever this component plugged into, we want to unplug it and plug in the new one, and unplug it and plug in the new one. So we have that one. Let's see. And we want to plug in this one down there. Let's unpreview this, see why it's not working at the moment. Okay, so let's start over with the lofts here. Let's loft together the top curve. So we'll loft this one, the top, and this one. We'll have to flatten it. That's the reason why it didn't work last time. And then let's loft this curve and this curve, create the bottom one, and we'll loft together this top one and this one. I think we already have that. I think it's this one. Top and that outside one. So let's plug this one in and let's flatten it. And so there we have, I'll flatten this one also. So let's preview all of them and let's join it together once again, as we did before, but now with this offset, which will allow us to 3D print it accurately without it having overhangs. So unpreview that, we can unpreview the curves, and we can take a look here and see, yes, that's exactly what we want. We want that slope going up. We could decrease the offset to create a bigger overhang, or not an overhang, but a better angle here. And if we take a look at the bottom portion and the top portion, we can see that we have a 3D printable egg which I like to group together and flatten it. That way we have a grouped egg. So this is going to be something that I'm going to 3D print, and I'll give you an idea of what it looks like as a final product. Let me go ahead and bake this. I'll preview this and then show you. Change the object layer here. Okay, so once I ungroup it, bring it up, there we have this 3D printable egg that you can vary, you know, many of the parameters here to, you know, depending on whatever you whatever you're looking for. So there's this egg. We can increase the scale. We can increase the size. Go to 1.5 here. And the thickness of the wall, we can make it, you know, 3 millimeters, or you can make it really thick. And so I hope you enjoyed this tutorial. This will be for anyone that's trying to 3D print or, you know, create a form like this that can open and close. I will make sure to clean up all of this and have a link for you to download. Let me know if you have any questions or if you want to see any other tutorials, and thank you for watching. Okay, so here are the 3D printed eggs that I kind of gave you an idea of the tutorial, and they turned out pretty good. I'm going to put the camera down for a second and show you. Let's see, I don't know if it's focused right. But there you go. You can 3D print it, you can open it, you can close it. Let me show you here. So here it is, the 3D printed egg. I did this with clear PLA. And it turned out pretty good. And this is something that you can kind of close here. It's fairly tight to close and fairly tight to open, but the quality turned out pretty good. I really enjoyed the way this turned out, and so I hope you enjoyed the tutorial. I feel like it's going to be very useful for anyone that's trying to do 3D printing, but also, you know, wants to learn some Grasshopper. I want to create a new Thingiverse account so I can post these and have people, you know, be able to download them and print them themselves. So I will create other iterations, and yeah, I hope you enjoyed the tutorial. Let me know if you have any questions or ideas for other videos. Thank you for watching.